Mm, 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 mm. Okay, let me see something. Okay, hello, hello, hello. Mic check, mic check. Let me increase the volume. Okay, hello, hello, hello. Mic check, mic check. Okay, so it is working fine. So, uh, okay, so today I will be solving all the remaining questions, right? How many questions are there? Let me see. One, two, three, four, five, six, seven, eight, nine, 10, 11. Okay, so 11 questions are there. Okay, fine. So let me start with this. Okay. Okay, fine. Let me reset the code. Okay. Wait a second. Okay. Uh, so what went wrong here? You are given an array. Okay. So what in this question, what I have to do was make the sum arrays equal, right? Both the sum equals, right? Right. I know the maximum and minimum sum of this, maximum minimum sum of this. And what I did was I used a binary approach that how many character need to be changed. Okay, let me see which of the test cases it pass. Okay, it went wrong here. Let me see. Okay, so the minimum possible sum is 6 and the maximum possible sum is 36, right? Right. So if I'm talking about 6, right, then how many character need to be changed from this? This has a greater sum, right? And this also 2 to 4, 5, 6. This also has a greater sum. I think here it fails to do so. Okay, so low will be okay. This will be the range, right? What is this? Deck prefix. I don't know what is this. Okay, let me reset it. Is this question? Hmm. Okay, let me get some hint. Let's note that we want to either decrease the sum of the array with a larger sum or increase the array sum with the smaller sum. Yes, that's I know. Let's note that we want to either decrease the sum of the array with a larger sum or increase the. I know that. I know either I will decrease this sum or I will increase the sum, right? Hmm. I got the range, right? I got the range. Now what I need to do is, suppose I want a sum of 6. Then what? Hmm. Okay, okay, nums 1, nums 2. Hmm. Another hint maybe. You can maintain the largest increase you can make in binary search tree and each time get a maximum one. What this means? You can maintain the largest increase or decrease you can make in a binary search tree and each time get the maximum one. Hmm. You can maintain a largest increase, decrease you can make in a binary search tree and each time get the maximum one. That what was that also what I was doing, right? I know the maximum degrees from here I can make from this. Okay. Hmm. Okay, let me bring the back. So here what I did was I sorted the both array. Right? I calculated the sum. So I know someone will have now the sum which has larger sum. Okay. Prefix one will calculate the prefix right from the last end. From last end to the okay, and I will reverse it. Wait, what? I will reverse it. Why would I reverse it? Let's say one, two, sorry, uh, 1, 2, 3, 4, 5, 6, right? Okay. So what I am doing is prefix of n minus 1 will be less than 5. Okay. This will be prefix of I will be whatever this is, prefix of I plus 1. Whatever this is 5 plus this minus 1. So it has a value 5, 4, right? So 9, 9 plus 3, what? 12, 14, 15, and 15, right? So this will be the value, and I'm reversing it. 12, 14, 15, 15, right? Right. Hmm. Okay, I understood this. And for the increment part, if I need to increment this, what I'm doing is I'm calculating how many increment can I do. So 1, 2, 3, 4, 5, 6 will be, but it will be 5, I can 4, I can 3, 2, 1, and 0, right? So 5, 4, 9, 12, 14, 15, and 15, right? Hmm, interesting. It is same as this. Let me do one thing. Let me just see out the vector, right? Let me just see out the prefix one. First then I plus plus, see out, sorry, see out prefix one, I, L, let me copy this. Instead of prefix one, let me see out the increment one also. Let me see. What is this? 5, 9, 12, 15, 15. Is that right? And 5, 9. Okay, it is the same. That is correct. Okay, wait a second. Hmm. Okay, it will be offline. Okay, okay. Today is 9, right? Okay, fine. Hmm. Then what? Then for the decrement part, sum to, wait, someone has greater, right? So prefix to this is the increment, right? So prefix to will be the increment. So it will be what? 1, 1, 2, 2, 2, 2, right? So prefix to will be how much I can increment this. So I can increment 4, this 4, this 4, this 4, this 5, 5. So 4, 4, 8, 12, 16, 21, 26. So this will be the, right? Also I need to reverse it, right? Now I'm starting from the this much. Okay. I'm starting from the first index as equals to y. Okay, I need to do a maximum increment. So okay, so this will be what 5, 4, 4, 4, 4, right? Okay, so in this direction. So 5 for 10, 14, 18, 22, and 26. Okay. For the decrement part, it will be the same, but reverse. Same as this, I think, in my opinion. Let us see. Mm, or let's, instead of INC, it should be DEC. And this should be prefix to. Let me see it again. Keep overflow. Boy, I is less than n, prefix to. Okay. Wait, what happened? M. Okay, it should be M. Hmm. Wait a minute. What happened? Okay. So let's see. So it is 5, 10, 14, 28, 16. 5, 10, 14. Okay. Wait, what happened to the decrement part? Decrement part is wrong, right? Where is the decrement part? INC, this is the decrement part, right? So what I'm doing is decrement part. So this one is what? Uh, 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 hmm. Deck of I will be nums2 of I minus 1. So this will be 1. And if I is I less than no, okay, so I will come here. So deck of I will be 1. Yes, I less than, so it will be added to 2. 1 is 3. So 4 and 4 and 4. Okay. And reversing it will be 1, 2, 3, 4, 4, 4. Okay, okay, fine. So what I'm saying is, okay, while low is less than high, operation is 0, C out low, okay. Okay, I'm calculating the difference, diff 1, okay. I got the both array. I'm calculating the difference. Okay, let me see. You can, okay, what will be the sum now? 1, 2, 2, 4, 5, 1, 6, 1, let's say. 2, 2, 4, 5, 6, 7, 8, 9, 15, 5, 4, 9. Sorry. Okay, so at 15, this will become equal, right? So at 15, let's say, uh, let's say I'm at 15. So 5, 9, 12, 14, 15, 15, and the array is 4, 4, sorry, 1, 2, 3, 4, 4, 4, and the difference array is 1, 5, 10, 14, 18, 22, and 26. Okay. So sum is 15, right? So I'm calculating. If someone is greater than, look, I'm checking whether I need to increase the sum1 or decrease the sum1. So currently someone has how much sum? Someone is having greater than, right? So I need to decrement the someone. So someone is not greater, someone, yes, someone is greater. So I need to decrement it. So what I did, I found out the lower one, prefix one. Prefix one is what? I think this one. And different. Different is how many difference. So it will be, let's say, 6, 6, 4, 10, 5, 5, 10. Currently the difference is, sorry, currently the sum is 21 and the sum I was looking for is 15. So 15 minus that is 6. So I need to decrement 6, right? I need to decrement the 6. Okay. I need to decrement the 6. So diff one is 6, right? Okay. So I found out the lower bound. So lower bound of 6 will be either 6, so it will be this. So I need to make how many changes? Two changes here, right? I need to make two changes here. All right. And if talking about the sum 2, then what will happen? Sum 2 has currently what sum? So it had 2, 2, 4, 5, 6, 7, 8, 9, 10. It has a sum of 10, right? I need to include. So sum 2 has low. Okay, it should be sum 2 here. Mm, okay, sum 2 is low, right? Sum 2 is is equal. Okay, sum 2 is less than low, right? So diff 2 will be what? Diff 2 will be, I need a sum of 15, so 5. Diff 2 will be 5. And what I need to do is, I need to increase the sum, right? So what about increment? Where is the increment part? Increment part, I think it is in prefix 2. Yes, increment part is prefix 2. So this one is increment. So I need to 5. So lower bound is 5 is this one. So this one is 1. So 2 plus 1 is 3. 3 operation are needed. So what the hell is going on? Let me see. Okay, let's say low is 15. High is also 15. Okay. Now what? Okay, low it gets printed. Let me just comment this out. Okay, this two. Uh, okay, let's see out the element. And here the element will be t minus prefix, sorry, this will be element. Okay. What I will do, I will say out the element. Let me see if it is working fine or not. What happened? I declare it right here. Okay, so this integer element. Bro, here is a declaration element. Okay. Hmm, One? What do you mean one? 15? One and zero. Wait, what? 15 is the okay low. Wait, why it is giving one? Why it is giving one? See out star of IT. Wait, what? The star of IT. Star of IT is 9, right? Yes. So it should be plus one, I think. Hmm, okay, but now Play Store is giving wrong answer. Let's wait a second. Okay, I will remove this. Okay. Okay, okay, wait a second, wait a second. Plus one, plus one. Okay, looks good. Yeah, okay, okay. Uh, let's see if this is working. Okay. We comment this out. Is it now working or not? Okay, now it is working. Okay, it's rupees 3. Should I submit? Let's wait a second. Where I'm pretty low. It comment this out to. Hmm. Now it is working. Submit. I submit. Oh no. 61 test case passed. Okay, so output is 2, expected is 1. Why? Output is 2, but expected is 1. Hmm. Is that, is it something? Okay, it should be, if, I think there should be a equals. I think it should be, it should be not be equals, right? Then I think it should be my issue. If it is equal, then I don't need that much operation. Yes, that was our thinking. Hmm. Okay, it get accepted. I wrote a very bad solution for this. Let me, the time complexity of this solution will be, but I'm pre-computing, so it will be of n m. And what I'm doing is I'm creating a low and a high, right? So maximum sum will be 6 into 10 to the power 5 this. So this will be linear, and I'm doing a binary search here, so it will be log n again. And log n maybe time complexity. Let me see some other solution. They also did the same thing with me. Wait, what? Move on to the next question. Hmm. Okay. Hmm. Hmm. Let me read the solution. So they calculated the sum, and if someone is greater, then they swap. So they are saying that okay, sum two. So nums two will be having the larger sum, right? And larger array two. Okay. So from here, someone okay, sum two will be greater. Okay, okay. Now our task is to make both S1 and S2 by equal by some good operation. That is right. We have two ways to do that. Either increase some element to 6 in nums1 or decrease some elements to 1 in nums2. So but now our task is to make both S1 and S2 equal by some good operation. Yeah, either increase some element in nums1 because nums1 has lower sum, right? Or I can decrement the nums2, right? So first of all, I calculate the difference. If difference is 0, then don't worry. So I created a vector array and for integer auto nums in array dot pushback 6 minus x 6 minus okay 6 minus x signify how much increment it does if we change element x to okay I know this nums1 has a smaller sum, right? So I need to increment it. So I'm looking for that how much increment can I do? Okay, that also what I did. Similarly for this, it says that how much decrement I can make. It is if it is one, I can make no change. Okay, then I sort this reversely. Okay, so they pushed all the in this. Okay, okay. Hmm. Okay, so there will be what some number of increment and some number of decrement operation, right? So for integer x in array, I'm incrementing the answer diff minus equals to x. Okay, okay. If difference is less than equals to 0, then return answer. At some operation may diff will be equals to 0. If diff is less than 0, then we can adjust last operation to our needs. That is, difference is greater than 0, right? Yeah. Yes, yes. So, okay. So either we can decrement it or increment it. Okay, okay. I think this makes sense. So they are reversing sorted in reverse order. So the first element will be the maximum, right? So if I am choosing the maximum one, okay. And if the what if the operation is what the operation if the difference is still greater than 0, then I will choose the next maximum possible. If any moment, if it is equals to 0 or is less than 0, it means we can modify the last index so that it is not less than 0 or equal to 0. Okay, this is a good solution. It will be in what? Off and login because they use sorted here. Okay, this one is good. Your solution is very elegant, but sorting makes okay. I inverted using counting. Okay, so again they swap this. Difference is greater than 0. Minus take is 6 and 0. Okay. This one is too good. Okay. So here we know that array element will be from 1 to 6, right? So this guy calculates the frequencies of that. And from this, he will what? He will choose the fifth from 15 onward. Okay. This one is also good. How to vote this? Okay, this one is also good. Hmm. Okay. Uh, Maybe I calculated some lengthy operation, right? So, hmm, this one is good solution, right? This one is good solution. But I will always choose the maximum I can reduce. Maximum difference I can reduce. I need to make the difference equals to 0. This is very good solution, I think. Okay, let me move on to the next. What is next? Let's see this one. Okay, so this question here, what we need to do is maximum consecutive, right? So we need to check whether I can make 0 or not. I can make 1 or not. Hmm, that is interesting. Question here, what we need maximum consecutive, right? Okay. Uh, did I submit any vote? No. Hmm. You can, so here, okay. So there's saying me return the maximum number of consecutive values that you can make. Okay, you can make 2, so 0, 1, okay. You can make this. Maybe I can use minus first, maybe. Let's say I can make 7. Then I know for sure that the left answer, so the answer will be in the right? Yes. So let's say I cannot make 18. So then I know that from 18 onward I also cannot make. So I will look in the left solution. Okay. 4, 1, 1, 1. Okay. So the question turned out to be given a particular sum, let's say 7. Can you make 7 from this array or not? The question turns out to be this, right? So let's say 7. The question turns out, can you make 7 from this or not? Hmm. Can you make, can use this or use this, that? Okay. First of all, I will calculate the whole sum. I know the range will be what? Equals to this, 1 greater than this, right? And low will be what? Low will be 1 because 0 I can always make. So answer will be by in the range of 1 and 1 greater than the whole sum, right? Hmm. Let's see. Given in sum, can I determine whether I can make this? And I need to only choose one, right? Hmm. Maybe I can use a sequence because I only need true or false. Whether I can make this sum or not. Let's say Let's say 1, 1, 1, 4. I need to see whether I can make a sum of, let's say 5. Let's say it is 1, 1, 2, 4. Can I make a sum of 5 or not? So what I will do is I will, let's say there is no one. Let's say I take 2, then I am looking for 3. Okay. How do you calculate it? 1, 1, 2, 4. Mhm. How do you calculate this? The coins of I is 10 to the power 4. 10 to the power 4 into 10 to the power 4 will be 10 to the power 8. Right? So I need to use the minus. Hmm. Let's say for a sum 5, can I use this? First of all, I need to see whether it is in range. If it is in range, then maybe a possibility. Then maybe I can break it. I will so okay 1 plus 4, 2, 2 plus 3, 3 plus 2, 4 plus 1, so half. 1 plus 4, okay. Hmm. This is something interesting. I need to see whether I can make this sum or not from using these coins. Is it different? Mm, okay, okay. How can I do this? I can do this, but it will be a big problem, right? I can generate all possible sequence and see whether if there is a sequence where sum is equal to this, right? That will not be optimal, right? Hmm. What can I do? What can I do? What can I do? 1, 1, 1, 4. I cannot use greedy approach. Why? Can I use greedy? Because I don't know no, whether if I choose 4, I don't know whether what I will have option again. Hmm. Okay, so let's say I approach a DP approach, then what? I am looking for a particular sum and a particular index. So will this get optimized or not? Let's see. Let me write a recursive solution, then I will try to optimize it. So I know my answer will be what 1. So let's load will be 1. Uh, what I will do is let's say console size okay, for integer equals to 0, a less than n, I plus plus. So my high will be let's say initially it is 0. My high will be the sum of all these elements. I plus equals to coins of I, right? And it will be one more than right. So let's say it starts from 1 on. Okay. So my low is okay, fine. So let's say I created a bool checking whether it is possible or not. So check. Here what I will just need is I will need a index I. It is sum and a vector of coins. I need to sort these coins first. Let's sort these coins. Although I don't need to sort this coin, but let's say coins coins dot size. It should coins dot begin. It should be coins dot end. Okay. Now for the check, what I need to do is uh, either I will include this. So what I will do is return. Either what I will do, either I will use this so sum will be reduced to but coins of I. Some will be sorry. Some will be now reduced to this coins of I and coins or so whichever one gives true, I will use this. It will move on to the next, right? So either I am using this or I am not using. So I plus one, some will return remain same and coins, okay, okay. And if any moment if sum is equals to zero, then I should return true, right? If but if if what if sorry if I is greater than equals to coins dot size, right? Sum is not greater than zero, then I will return false. So this will be the only base case, right? Hmm, correct. Anything else? No, I don't think so. Anything else? So what I will do is integer, but mini. Let's say int max, not int max. Let's say high, right? While low is less than equals to high, my mid will be what? My mid will be low plus high minus low by 2, right? My mid will be this. I will check of this 0 and this mid, this coins. If it is true, then what I will do is I will store it in mini. Mini will be now mid, and I am looking for the right hand side. So left, sorry, low will be now my mid plus 1. Else, if it is not possible, I will go on to the left. So high will be now mid minus 1, right? And in the end, what I will do, I will just return the this mini, what I just calculated. Okay. All right, all right. Wait, what? We're saying. Okay, okay, I understood. Oh, sorry. My mistake, my mistake. So there is a possibility that some 6 has been made, but there is a possibility also that 5 is not possible, right? Let's say 2 and 4. 2 and 4, right? 6 is possible, but 5 is not possible. So, okay, sorry. What I'm thinking, I think so I should take this as a linear. Okay. Need to reset. Okay, so what I will do is I will start from where? Uh, I don't know what it do. Okay, okay. So I have to do this in linear, right? So for one, I need to see whether one is possible. For two, I don't know how to do this. Let's take a hint. If you can make the first x value, and you have a value, then you can make all the values. Wait, what? If you can make the first x values and you have a value b, then you can make all values v plus x, all the values that are v less than equals to v plus x. Wait, what? If you can make the first x values, let's say I make the first four, let's say I make the first three values, right? Yes. And you have a value v, then you can make all the values v plus x. Oh, wait, he's right. Let's say I can make three. Wait, what? If you can make the first x values and you have a value v, then you can make all the values which are less than v plus x. Is it right? I don't know. I'm not able to think it correctly. Let's say I make 0, I make 1, I make 2, I make 3, I make 4. Now I have a value 5, right? Now I can make all values till 9. That is correct. You can make 5, 6, 7, 8. Okay. You can make 5, 6, 7, right? You can make 5, 6, yes. Oh, that is right. Why didn't you think of it? Hmm. That is true. So, let me now think it again. Let's say for 0. Let's say the coins are 1, 1, 1, and 4. Okay. I have a coin of 1. And till now, 1 is being okay. So, I can make 1. Okay. I now have a 1 of coin 1. Okay. I can okay, make 2. I can make 3. I can make 7. Oh, that is interesting. 1, 1, 3, 4, 10. Okay, I can make 1. I can make 2. I can make 5. I can make 9. I can make 19. Hmm. I think I now got the solution. Solution is first of all sort the coins. Then what I will do is for equals to 0, I less than, sorry, I less than coins not size, I plus plus, let's say sum is 0, let's say maxi possible. So maxi possible will be plus equals to whatever the coins of I is have. In the end, I will return 1 plus maximos. Wait a second. I have a value 1, 3. I can make what 1? Okay. I cannot make. Hmm. Okay, here is the hint. If you can make the first x values, you have a value v, right? You can make what? All values less than equals to v plus x. Hmm. What is this? Okay. If you can make the first x values and you have a value v, then you can make all the values less than equals to v plus x. So I have the first one value, right? And I need to make the first what? Less than v plus x. And you have a value v. 3 plus 1 what? 4. But I cannot make 2. Sort the array here and did that. I think there is some issue here. Let me think it differently. Hmm. Okay, okay. So I have a value 1, right? Let's say I want to make 2. So for 2, what values do I need? So maximum possible I made is 1, right? So if there is a value, maximum possible is 1, right? I need to make a value 2. So I need another one or any value that is less than 1, not less than 1. Let's say I make 0, 1, 2, and 3. Let's say, okay, let's say 4 also. Let's say, okay, then I want to find out whether I can make 5. I know that I maximum, I found 0, 4. Okay, so what do I need to do now? Hmm. So for 4, I need another one, or for 3, I need another 2. Coins of I. Can make the following values. If you can make the first x values and you have a value v, then you can make all the values which are less than equals to v plus x. Okay, okay. Oh, sorry. This should not be like this. It should be what? So let's say value I'm looking for is 1, and I will go on till, okay, I will go on till I exhaust all the coins. So value I'm looking is for 1, right? So value I'm looking for is 1, right? Uh, let's say all values will be what? Currently maxing pose plus this coins of I, right? Okay. So the all values I can make is from 0 till 1, right? Okay. Hmm. But then only it will be issue. Let's say I'm looking for value, what? 2, right or wrong? All values, let's say value is equals to 1, that is fine. All values equals to maxi pose plus coins of I. That is interesting. Mm, Value I'm currently looking for is this. Okay. Mm, All values I can currently make is this. Okay, let's say, okay, currently I can make only one value. Okay, fine. And I'm also looking for the value 1. That is fine. So next, I will be looking for the value 2, right? And now I have what? Now I have 3. Now I have what? 3. What that mean? That means, hmm, so maximum possible I can make is right now 4, but I'm looking for the value 2, right? So 0 1 I can make. I'm looking for 2. So I need another what? I need another 1. If it is 3, then it is a big issue. So let's take another hint. Process the value starting from the smallest and stop when there is a value that cannot be achieved with the current x. Smallest. Stop when there is a value that cannot be achieved with the current x. That also what I'm doing. Okay. Uh, 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 uh. What can be the issue? Mm. Okay, let me think clearly. So if I have a value, let's say if I value, if I determine the first x values, that is fine. And I have a value, let's say 4, then I can make all the values from, okay, that is good. So I have 1, 4, 0, 1, 3 plus 1 is 4. I can, wait a second, I cannot make 2. Because I have 0, 1, I have value 3. So 3 plus 1 is 4. If that is right. But how it is now? I can make 3, I can make 3 plus 1, 4. But what about this middle? Okay, so this is something edge. So let's say 0, 1, 2, 3. Now I have a value 4. So I can make 4, I can make 5, I can make 6, I can make 7. So this is something edge case, right? So let's say 0, 1, 2, 3, and I have value, let's say 5. So I can make 5, I can make 6, I can make 7, I can make 8, but I cannot make 4. Okay. Oh, okay, 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 okay. So maxi pose will be this. Okay, let me write out one more solution. Okay, so maxi pose will be whatever the coins I have currently, and that will be the maximum. Okay, one thing I need to do is if maxi pose, wait, but here, okay, maxi pose, if maxi pose is odd, right, and the coins of I is also odd, then I should break. Because that is the only reason when it is not possible. What happened? Did you mean coins? Coins. Yes, yes, I mean coin. Phew, what is the wrong answer? Basically. Wait. 1114. So I can make 0. Okay. Okay. And but they both are odd. But when should I solve? Maxi pose plus 1 is not equals to maxi pose plus coins over. Wait, what? What are you writing? It get accepted. I don't know how. Let's see. Let's write a random test case. Let's say it is 3. Let's say it is 5. Hmm. I got the wrong answer by 1445, right? So 1 is possible, okay? Okay. So I can make 5, but I can make 2, 3. Okay, okay. So from maxi possible and the value which I have currently, and from 0 till here, need to make this. So if I have first let's say 0, 1, 2, 3, 4, I have, let's say 7. So I can make what? I can make 7, I can make 9, 7 plus 4, 11. Okay, I can make all these. I don't know about this. Okay, whether I can make 5, whether I can make 6. Using this value, I cannot make, right? And this is the maximum value I now have. That is right. Hmm. That is the maximum value I now have. Okay. What can I do now? So, in my opinion, what is happening is, let's say I have, let's say 0, 1, 2, 3. Now, let's say I have a value of 7. So, I know I can make a value 7. I can make a value of 8. I can make a value of 9. I can make a value of what? 10, right? I don't know about the in between. In between will be what? So 4, 5, and 6. What about these? These will not be possible, right? Hmm. Okay, let's take this example. So it is 1, 1, 3, 4, and 10, right? So currently I have 0. So I can make what? 0 plus 1. So I can make 1. Okay. So now come this 1. I can make what? 1 plus 1 is 2. I can make 2. Let's say 3. I can make 3. I can make 5. I can make till 5. Okay, 5. Okay. I can make 5. I know that 3 can be made. 4 also can be made. I have now 4. So 0, 1, 2, 3, 4. I have 4. Right? I have a value 4. Mhm. So 4, I can make 4. I can make 5. I can make 6. I can make 7. I can make 8. I can make 9. Make 9. By 4 is this, is this, and that. So here, how it is possible to make this? This one is what? 3. Okay, it is 10. Okay. So let's see. Okay, I can make 0. Okay, I can make 1 using this. Okay, I can make 1 plus 1 will be 2. Okay, now 3. 3 is just 1 greater than this, right? So it is always possible. So 3 plus 2 will be 5. So I know for sure that in between elements will be always make. Okay, so 3, 4 will be always make. So 4. So value 4 is less than this. The value 4 is less than this. So I will also increment it. So now 9 is also possible. Now the value is 10. 10 is just 1 greater than this. Okay. So it will also get incremented. So 90 is possible. So last is 20 is not possible, right? Yes. So from this I understood that if the value is just 1 greater, then I will always accept it, right? So this one come here. And if the value is less than or equal to, then also I will accept it. But when will I not accept it? Let's say the first example 1, 3. So 0 is possible. 1 is just 1 greater than this, so I will accept it. Now the 3. Now 3 is greater, but 3 is not just 1 greater than this. So this is the stopping point. So the answer should be 2, right? And for the answer, yeah. So, Maxi coin will be okay. So if the coins of I, sorry, if coins of I is just greater than the whatever maxi pose I have plus 1. So I will include that in my answer. So maxi pose will be what? Plus equals to coins of I. Okay. If it is less than this, if coins of I is less than this, or let's say coins of I, if it is less than or equals to, then I will, okay. Else I should break. Let's see now. Let's see now. Okay, now it is accepting. Let's submit it. Okay, now it get accepted. Okay. Hmm. So the time complexity will be for this, it will be log n, not log n, sorry. And log n, this is linear. So the overall time complexity will be n log n, right? Follow-up question. Tricky one. Okay. So I think the major part is this hint, right? If you can make the first x values and you have a value v, then you can make all the values which are less than v plus x. Hmm. You should return the minimum number you can make with your coin starting including this equals to return the minimum number that you cannot make. What they have done, they have sorted this. If a is greater than rest, break. So they have also done the same thing. Hmm. Okay. Let me do some different question now. Okay, so this one question, I think it is very good. Hmm. So in this question, what I need to do is what the min product of the array is equal to the minimum value in the array multiplied by the array sum. For example, 3 to 5 minimum value is 2 and the minimum product is, wait, what? For example, the array is this, okay. Minimum value is 2, 2 multiplied by the sum of this. Given an integer and nums, return the maximum min product of a non-empty subarray. Okay, so I need to check for the non-empty subarray. Okay. Hmm. Okay, okay. So I thought about this question. So for this, in my opinion, what I need to do is let's wait. Hmm. So let's talk about this, right? So 3, 1, 5, 6, 4, and 2, right? Hmm. So the question says that I need to find the minimum of the subarray, minimum of the subarray multiplied by the sum of the subarray. So to maximize it, because they are saying that I need to maximize it, either I can maximize this or I can maximize this, right? So either I can maximize this or either I can maximize this. So what I can do is, let's say I calculated, let's say I, but I, let's say for what I will do is for every element, I will say that okay, this is the minimum element in my subarray. Let's say I'm considering this, right? Okay, I will say okay, this is my minimum element in my subarray, and from here onward, I will expand the array. Okay, so I'm saying this is the minimum element, right? So can I take this 6? Yes, you can take this. Okay, can I take this 4? No, because I'm saying this is the maximum, right? So this will not be my in my array, right? So only this will be bad. So from left hand side, will this will be my in my subarray? No. So only this one is right. Okay. I can calculate the prefix sum of this array using prefix sum. So minimum I know is 5. So 5 multiplied by 6 plus 5, 11. So 55. Okay. That is still not maximum. Well, let's take this 6 as the minimum element. Wait, they are saying 4. Okay, let's say let's take this 4 as the minimum element. I'm considering this 4 as the minimal element. So I will look on to the right hand side. Can I take this 2? No, you cannot take this 2. Can I take this 6? Yes. Can I take this 5? Yes. Can I take this one? No. So the sum is what? 15 and minimum is 4. So 15, 4, 60. So this is the maximum, right? Okay. So I can write first of all, but so this approach is n square because I am for every element I'm calculating and I'm expanding to the left and right. I can calculate the perfect sum or the sum of the sovereign of one using prefix sum, but somehow I need to calculate that how many index should in left will I go in of, let's say, 1 or log 1 maybe. Then only I will be able to solve this. Mm, 315642. Okay, 315642. Okay, let's say 6. For this, I know the maximum will be what? This index is 0, 1, 2, 3, 4, and 5, right? Let's, if I'm considering this as the minimum element, then what is the maximum right boundary I can go to? I can go till here. So I can go till 4 in my right boundary. And in my left boundary, I can go till this. Okay. I need to calculate this for every element, right? How can I calculate it? This will be 5, right? How can I calculate this? So for this, I need to find the first element in its right hand side that is less than this. But I need to find the first element in the right hand side that is less than this. This is how to calculate this. Let's say, let's say I'm iterating on the array, right? Let's say I'm first of all I'm considering 3. Okay, so for 3 I am not, but let's say for the 3 I have not calculated the solution for this, right? Okay, then I will move on 1 here. Okay, so now currently I'm at 1. If there is an element, sorry, but is there an element I previously not solved? Yes, it is. There is 3. And is the element that I am currently in is less than that element? Yes. So the answer of all those element will be what? That index. So for the 3 it will be 1. Hmm. So for 1 still I am not able to solve this, right? So I will move on till here. I will say okay 5. Okay. Is there any element that is less than 5 and still not solved? Less than 5 is, sorry, is there any element that had been not been solved and the 5 is less than that? No. Okay, so for 5 still not possible. Okay, let's come to 6. I'm I'm at 6 now. Now, is there any element, what? Is there any element which has not been solved and for them the 6 will be the value? Uh, I need to find the less than 1, right? I need to find the less than 5. But 6 is greater than both. So it will not be our solution. So 6 is still not correctly placed. Okay, now I'm at 4. Is there any element? Okay, so 4 is less than 1. No. 4 is less than 5. Yes. So for 5, this will be the solution. So index 4 will be the solution. And for this, 6 is 6 less than, yes. For this will be the solution. Okay. Okay, so I can do this. And for this one, this whole for this one, the right hand side will be what? 6. That means I can take all the values from this. Mm, How to do this in login maybe? So maybe I can do what? Maybe I can create an array. I can create an array like 0, 1, 2, 3, 4, and 5, right? And here I will store the what? My answer. Mm, eh, let's see. Okay, so these are the element, right? So currently I'm at 0th index, okay? So I'm not writing 3, I will say, okay, I'm calculating for the 0th index answer. So 0 index will be still not possible, it's okay. Let's store it in a pair. So 3 comma 0. Okay, now commit 1. So 1 comma, now I'm considering 1 comma 1, right? Is there any element less than this? So no, not less than this. Is there any element, what? So 1 is greater than how many elements? Okay, so this, so there are these any elements, right? Okay, so it has a value 0. So for 0, this will be the answer. So for 0, it will be the one answer. Okay, so this will be what popped out, I think. I think so. And one will be now pushed because for this no calculation has been made. Okay, now comes what? Now comes 2 comma 5. Sorry, 5 comma 2. Element is first and index is second. Okay, 5 comma 2. Okay, can 5 comma 2 will be the answer for some? No. So 5 comma 2 is still pushed, right? Okay. Okay, now next element is what? 6 comma 3. Can 6 comma 3 will be the solution for any that has been not yet been solved? 6 comma 3? No. Yes, no. So 6 comma 3 will be now pushed. Okay. 6 comma 3 will not be pushed. Okay. Now coming 4 comma 4. Will this will be the solution? 4 comma 4. I will look for the what? Upper bound. Yes. So this, right? What this part is saying? Okay. This part is saying I need to find less than this value, right? I need to find less than this value. So for 4, I will look for the lower bound. So this will be the solution. So, okay. So I know that from here onward, whatever element were there, they all will have answer 4. Okay. So they all will have the answer 4. So 5 and 6 will have the, so 2 and 3 will be the answer 4. Right? How can I do it in login? Maybe what I can do is I can remove this element. So what is the time complexity then? Every element is what? Inserted only once, right? Okay, so okay, okay. Oh, okay. Then I can do. I think so. 4 comma 4 will be now pushed. Yes. Then comes 2 comma 5. Will 2 comma 5 be the answer for anything? So I will look for the, so 4 comma 4 will say okay. I will look for the lower bound of 2. Yes, this is this 4 comma 4. So for 4 comma 4, this will be the solution, that is at index 5. For 4 comma 4 will be the solution at index 5. And now 2 comma 5 will be pushed here. So there are no more element. So whatever is left, they will all have the index 6. So this means that this can take till the last index, and this can take till the last index. Okay, so for now, okay, similarly, I will do for the left part, right? Okay, similarly, so now I found the first index. Okay, let me code this up. Okay, so first of all, what I will need is I will need to find the what prefix sum. Let's nums of I is large, so I should use a long num. Nums dot size. Okay, so I will create a vector of prefix sum. It should be long num. Prefix sum. Okay, it will be of n size initially, but wait, but n 0. Okay, so for integer I equals to 0, I less than ni plus plus prefix sum of I will be nums of I. Okay, and if I is greater than 0, I will include the previous sum plus equals to prefix sum of n minus 1, right? Is it correct? Uh, eh? n minus n minus 1 should be I minus 1, right? Okay, now I need to calculate for the right. Let's say I created a vector integer right, which will store the first, which will store the first, which will store the first index on its right, which has a value less than that element. So I need to create a set of pair, say integer comma integer. So pair will be element comma the index st, right? St dot insert. I will create push the first element. First element will be nums of 0, comma what 0. So set is 0 string, and let's say index is let's say I. Okay, and now what I will do is for integer I equals to 1, I less than and I plus plus. Okay, let's remove this. So currently element I am looking for is element is what nums of I. Okay, so what I need to do is I need to find the what, let's say I need to find the lower or upper. Let's say I have a value 3 comma let's say 3, I have value 4, I have let's say 7, and I have value 8. Now these are on in the inside the set. So these all values are looking for a element, right? These all are looking for an element which can be their answer, right? Right. So 3 is looking for any element which is less than this. 4 is any looking for any element which is less than 4. 7 is also looking for an element which is less than this. 8 is also looking for an element which is less than this. So let's say this comes as 5, right? So this will not be the solution. This for this it will not be the solution. So it should be the lower one, not lower one, sorry, upper bound, because I can took the maximum value, right? I can took the equal value. So I will look for the upper bound. I will look for the upper bound inside the set auto iterator. Uh, st dot lower bound, not lower bound, upper bound of what this element, right? So if I found the what, so if it is not equals to st dot end, okay, if it is not equals to st dot end, that means I found some element. So what I will do is while it is not equals to st dot end, okay, index for this element is what I, while it is not equals to st dot end, what I will do is I will iterate on those elements, right? What I will do is, let's say I said that 3, 4, 7, and 8, right? And I have a value 5, right? But I have a value 5. So upper bound will be this. So I will iterate all these array and I will push that. Okay, for this the answer is 5. For this answer is 5. Okay. So, IT dot second, star of IT dot second, star of IT dot second. This will give me the index, and right of this index will be what, this index, right? This is the solution. And what I will do is, okay, I need to erase it also. So st dot erase this IT. Hmm. Okay. Let's don't let's let don't do this. Okay, let's take an auto iterator. Temp IT equals to IT. Okay. Okay. St. Let's not erase it right now. Okay. So it will go on till here, and for every element that is greater than this. Okay. Now what I will do is I need to remove this also, right? So while temp it is not equals to st dot end, I will erase that all also. St dot erase this temp it. I don't know it will work or not. I will increment the temp it. I don't know whether it will work or not. Hmm, let's see. Okay, so I calculate the prefix sum. I'm calculating the right part. Let's check whether it is working or not. But I need to. Okay, let's see. Mm. Wait. Should be element comma minus, let's say. Star of iterator will be n pair. So it should be iterator second. Let's miss. It's not a pointer. Did you mean used? Oh, sorry. It should be dot. It is a pair, right? Okay. Anything else? No. Okay. Let me check whether the right part is correctly working or not. Element in right. See out. Right. If it is working fine, then we will move forward. So let's talk about this. Hmm, what happened? Oh, no. Sorry, it should be element. Why this colavity? Wait, what? Minus one should not be minus one. Hmm, so I inserted nums of 0. Let's see. So element are 3, 1, 5, 6, 4, and 2, right? These have the index 0, 1, 2, 3, 4, and 5, right? Right. So initially in my set the value is 3 comma 0. Okay. And I is currently this, right? Okay, index is I, element is this, nums of I. I'm looking for the upper bound. Element comma minus 1. So I'm looking for the upper bound of 1 comma minus 1. Is there element? Hmm. Is it finding or not? I don't think so. It is finding. Okay, found. For first it found it. Okay, for first it found it. So in my set 3 comma 0 was present, right? Okay, I was looking for 1 comma minus 1. So I found the upper bound of this, right? Yes. So what I did here is, uh, oh, sorry. One thing I'm missing here is that I'm not inserting this back, right? So I should insert it. st dot insert this element comma this index. Okay, so this was my fault. Let's see now. I need to push this also. 1 minus 1, 4, 4, 5 minus. Okay, now it is working fine. Okay. So similarly, minus 1 means there is no, minus 1 means what? There is no element on its right that is less than that, right? So instead of minus 1, what I will do is, let's say I will, uh, what is the maximum? Let's say n, right? So now it will be this y not print. Okay. So left part is done. Now I have to do is, I have to create for the, what? I need to for the left part also, right? So left part will be similar, I think 3, 1, 5, 6, 4. So initially what I will do is I will push 3, 3 comma 0. Okay. Wait, I want to look in the left side, right? Left side. Okay. I want to look in the left side. So currently I have 1 comma 1. Okay, so it will be different. It will be from the right hand side. So initially, uh, 0, 2, 3, 4, and 5, right? So initially 2 comma 5 will be pushed. Now I'm checking whether this will be the solution of any on the right hand side, right? Whether this 4 comma 4 will be the solution. So again what I will do is I will look for the, because this one is saying that is there any value which has, okay, so again I have to, okay, so it will be same, but what I will do is, I will create a left array also, n comma, let's say minus 1 is this, so there will be no confusion. St, okay, let's create another set, st here, integer comma integer, let's name it st2. And now for the left part I will insert it from the what, uh, right hand side, so nums of n minus 1, and the index will be n minus 1. Okay, and what I will do is I will iterate on the second last element till first minus. I think same will be here. I think same will be here. There will be nothing change. Wait, what happened? Okay, sorry. Okay, so element index is there. I need to find the, okay, so it should be st2. I need to find the upper bound. If it is equals to, okay, temp it, okay, it should be st2. This should be st2. Okay, st2. Okay, this should be st2. Okay, and this should be st2. Okay. So let's see the right hand side, or sorry, left hand side for auto ampersand left in, what, sorry, for auto ampersand left. Let's see out the left part. Okay, whether it is working or not. Let's see this. uh, Not left, bro, element. Minus 1 what? Minus 1 what? For 3 it will be minus 1, right? For 1 it will be what? Minus 1. For 5 it should be this, right? What is happening? Okay, let me try run. So 3, 1, 5, 6, 4, and 2, right? So and index is 0, 1, 2, 3, 4, and 5. So currently 2 comma 5 is pushed. Yes. And I'm considering this 4 comma 4. Well, 4 comma 4 will be the solution. I will look for the upper bound. Wait. Yes, okay. Hmm. Wait a second. Here I need to find the less than this, right? I need to find the less than this. Okay. So I found the upper bound. This one is the upper bound. Okay. Is there any element which is less than this 2 comma 5? Okay. Wait a second. Well, this will be the solution to any of this. Okay. Okay. Oh, sorry. This is the set, and this is the element I'm currently I. So I is here, right? So I will do a upper bound. Okay. So there are no element. So this will be what? Sorry. This will so for this no calculation. So 4 comma 4 will be pushed. That is fine. Now currently I is here. Right? Currently I is here. Okay. So 3 comma 6. So sorry 6 comma 3. Well 6 comma 3 will be the answer to any of its. Okay. So for 2 no. For 4 no. So this also will be what? Pushed back. So currently I'm at 5. 5 comma 2. Is there any element on its right hand side will for which this answer will be given? So what I did was I found out the upper bound of this. Upper bound of this will be this. Okay. So for this 6 comma 3. Okay. So for this will be the index. So 2. So this will be the answer of this. Right. So this will be popped out and this will be now pushed. So now 5 comma 2 will be pushed. Okay. That's fine. 5 comma 2 is pushed. Now come see this 1 comma 1. Now it is interesting. Now 1 comma 1 will be here. Upper bound of this. So all of these will have this value. All of these. So 5, 4, and 2. 5, 4, and 2 will be having this index 1, 1, 1, and set will become now empty. Right? And 1, 1 will be now pushed. 1, 1 will be now pushed. Okay. Now I'm at this. Okay. This is 3 comma 0. Upper bound of 3 comma 0 is nothing. 3 comma will be here. Okay. Nice less. Okay. So these will have value minus 2. This will be. This should be the solution. Minus 1, minus 1, 1, minus 1, minus 1, 1, 2, and 1, right? Okay. Why it is one? So let me see. Element will be nums of I. That is fine. Index will be I. That is also fine. I am looking for the upper bound. St dot insert. If it is not equals to st dot end. Temperature will be, sorry, temp it. Okay. Oh, sorry. This will be it2. Okay. Now it should work fine. Where? What is this? It should be index, right? Okay. Wait, IT2. Wait, what? Hey, it should remain IT. Uh, element nums of I, looking for the upper bound. It is not equals to st dot and temp it, while it is not okay. It plus plus. Oh, should be left. What the hell? I'm calculating for the left part, right? Not right part. Okay. So sorry, minus one, 1, 2, 1, 1. Minus 1, minus 1, 1, 2. Okay, so this one is also, what is this? 4. It should be this, right? 1. Why it is giving me, no, no. Why it is giving minus 1? Wait a second, wait a second. Should not give me minus 1. Why it is giving me minus 1? For 2, it is giving correct answer to 1. For 4, it should be, right? Wait, what? Minus 1, 1, 2. It should be 1 here. What is happening? Mm, 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 mm. Mhm. My God, what is happening? Let's see. Let me try run again. I don't know what happened. So, 3, 1, 5, 6, 4, and 2, right? So, 2, comma 5 is pushed into the set. This is set. And I is currently here. So, this is 4, comma 4. 4, comma 4. So, what I did, I found the upper bound of this. There is nothing. So, 4, comma 4 will be now here pushed. Okay. Okay. Now I'm at 6. I know 6 comma 3 will be not be the solution. Okay. Then I come at 5. Okay. For 5, I know this will be the upper bound and 6 comma 3 will be now popped out. And for 6 comma 3, the answer will be the whatever of index. So 0 and 2. So for 6, it will be 2. So for 6, it is 2. That is fine. Okay. And now this will be pushed. So this is what? 5 comma 0, 1, 2. 5 comma 2, right? Okay. Okay. Now I'm at here. This is 1 comma 1. So upper bound of 1 comma 1 is what? This one, right? So for 2, which is at this index, this will be the now solution, right? So it dot second. So this, so left of this 5 will be this index 1. So left of 5 will be 1. Okay, then moved here 4 comma 4. Left of 4 should be 1, right? That is even minus 1. And for 5, it also should be 1. It is even 5. But why minus 1 here? I don't know why it is giving minus 1. Am I doing something different? And minus 2, minus 1. Sorry. Hmm. Okay, okay. Other one, okay. Found out the upper bound. Let's say 82. Okay, let me just see out all the elements which are going to be delimited. Okay? Let's see out the index. Let's see what current I am currently in and what all the values are going to be decremented. Let's see out and then here. Okay. Hmm. God. Okay, so for Wait, what? I'm currently at index 2. So 0, 1, 2. For index 1, only 5, 2 are popping out. Why? Wait. Oh, did I sorted this nums array? No, I don't need to sort this array, right? Okay, no. Set of pair st2. Okay, set dot insert nums of n minus 1 and n minus 1. So this will be push, right? Great. Okay. Mm, what I was saying, okay. IT, wait, what? I star of IT dot second 2 comma 3. What is happening? st dot insert. So I inserted 2 comma but 5, and let's say I'm currently at 4 comma 4, right? And minus 2, I is greater than 0. Element will be what? Element will be 4 and index will be 4. So I found the upper bound. Upper bound is this. No, upper bound is end. Okay. Let me, okay. I inserted the element comma index. Then what happened? Currently I have what 2 comma 5 and 4 comma 4, right? So I is now this 6. Okay. For 6 upper bound, no, not present. 6 comma 3 will be there. Now comma 5. For 5 upper bound, so 0, 1, 2. Yes. Yes. So I found this one. So this one will be popped out, right? And I will push this 5 comma 2. Now for this one, this should be the upper one. For 1, it is giving me 5 and then 2. Wait, what? Oh, sorry, index, no? So 5 and 2. What happened to this guy? What happened to this guy, bro? Where did he go? What happened to this guy? Mm, bro, what happened to this guy? Where he went? So let's say for now, what I will do is I will for every eye, let's print it out. I don't know where it went. Let's say TR, TR, sorry, TR. This should be ST2. This should be ST2 also. ST2, okay. So what I will do is I will see out sorry, star of TR dot first and sorry, star of TR dot second handle and TR plus plus. Okay. Now just let's just calculate this. Remove this. Remove this also. Let's run this. Hmm. So okay. So here 4 comma 4 is present. So initially only 2 comma 5 was present, right? Initially 2 comma 5 was present. Then 4 comma 4 will be present. Right in second loop. Okay, fine. In third loop when 6 come. In third loop 6 comma 3 will be present. Okay. Okay, so for this is correct. For this is correct. For this is correct. Now for this, what happened? 4 comma 4. Where is 4 comma 4? Let's say, okay, for this, there is the problem, right? 5 comma 6. Hmm. Okay, let me see. Did I delete 4? Deleted number of time 30. Let me see. Did I deleted this? 11. My God. Deleted 6, deleted 4. Okay. 4 is getting deleted, but why? Why? Bro, it is a set. Why 4 is deleting after 6? It should be sorted, right? Oh, okay. Oh, my bad. No. Temp is ID. Okay. Okay. What is going on? Okay, so after deleting 6, temp ID will still remain 4, right? Okay. Okay, what is going on? Hmm. Mhm. Okay. Hmm, why this is going deep? Related 6, related 4, up, 2 or 3. What? 3. Wait a second. Okay. So what I did here is I pushed this right. Okay, I printed this. So for talent, okay, for okay, for this 4 it is fine. For this 6 it is fine. For this 5 it is fine. This 5 is fine. Hmm. It's going on and on. 254463. No, this sheet is something else. Yeah, this sheet is something else. So now my upper bound is 5 comma 2. 5 comma 2. 5 comma 2 should be pointing here. Deleted 6. Right, but now instead of this, what I will do is let's create a vector here. B and we dot insert this pair IT, sorry, star of IT. Star of IT will be a pair, right? We dot insert. Okay. So instead of this, what I will do is for auto, I'm using pair in B T2 dot erase this B. Will it work now? -1. Let me please work. Okay, now it is working fine. Okay, 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 okay. So, I will remove this. I will remove this. Okay, remove this. Okay, 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 okay. Here also I can do this, right? Okay, so I did this. Okay, 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 okay. Now what I need to do? I need to find the what? Since the answer may be large. Okay, so let's say long, long. Um, Answer let's say 0. So for integer I equals to 0, I less than n plus plus. So okay, okay, minus 1, 1, 2. Let me see. Okay, let's see this 3, 1, 5, 6, 4, 2, right? 0, 1, 2, 3, 4, 5. Okay, okay. And the answer for the left part is minus 1, minus 1, 1, 2, 1, right? Okay. So if I'm considering this, this means at this index, so it should be 8. So left part will be what? Your left part will be okay, left and right, right? Okay. If so, oh, so L, P and R, right? Okay. If left of I is equals to minus 1, so left will be what? Left will be 0. Minus 1 will be no element of there, right? Else LFP will be left of I 1 greater. Similarly, if right of I equals to minus 1, so right will be what? And minus 1. Else not GST uh, GT will be what? Minus right of I, right of I minus 1, right? And the answer will be maximum of answer itself and prefix sum. Prefix sum will be what? Prefix sum of right, sorry, GT, right? And if LFP is greater than 0, so sum minus equals to prefix sum of LFP minus 1. So sum multiplied by this I, that is num sum. And the answer I will not minus 1. See the response. You know, it's not even Mm.